The world of IoT is evolving at an unprecedented pace. Today, we're seeing millions of connected autonomous devices moving across industries, cities, and infrastructures in real time. From drones delivering packages to autonomous vehicles navigating our streets, these devices are transforming the way we live and work. But with this growth comes a huge challenge: managing and orchestrating these devices at scale. Traditional IoT solutions were designed with a priori knowledge of physical location of the static devices, with fixed deployments of services and deterministic workload requirements. Moving things traverse space mostly following unknown trajectories, therefore generating a heavyweight, dynamic, and non-deterministic IoT workload. As such, traditional solutions can't keep up with the demands of moving assets in real time. Businesses and telecoms face difficulties in maintaining connectivity, ensuring service continuity, and optimizing resources for such a large and dynamic network. As the number of devices grows, so does the complexity. Managing large-scale, real-time moving IoT ecosystems introduces new hurdles in resource allocation, network efficiency, and sustainability. At the same time, there's growing pressure for those networks to deliver revenue and to become more energy efficient and environmentally responsible. On top of that, the need for flexible, scalable solutions is critical as industries seek to maintain performance while also reducing costs and meeting sustainability goals. The question is, how do we scale IoT management for millions of moving devices, ensuring seamless connectivity and making it all sustainable? To address these challenges, we're introducing cutting-edge technologies that bring autonomous orchestration, real-time intelligence, and sustainability optimization to the heart of managing the Internet of Moving Things. Our solution leverages AI-driven orchestration, which enables devices to autonomously discover services and make decisions in real time. We'll be deploying intent-based networking, allowing us to manage dynamic networks with ease. This means devices can adjust their behavior based on preset goals and operational requirements, whether it's adjusting bandwidth for high-priority services or ensuring continuous connectivity for moving devices. We're also focusing on scalability. As deployments of moving things grow, our solution allows you to handle not just hundreds, but thousands or even millions of moving devices seamlessly. The system will adjust dynamically, ensuring that as more devices are added to the network, the performance and efficiency stay intact without manual intervention. Due to the increasing complexity and scalability of the Internet of Moving Things, operational management is multidimensional, involving the management of myriads of moving devices, their network connectivity, multiple types of data streams, IoT services deployed at the edge, and edge compute infrastructure resources. Therefore, we're focusing on autonomous management capabilities, catering holistically for all such dimensions. Based on advanced AI algorithms, these capabilities analyze system performance in real time to detect potential anomalies occurring in any of these management dimensions, discover remedying actions or optimizations, and automatically enforce feedback loops to avoid disruptions whilst guaranteeing service continuity. Furthermore, AI will be continuously examining the Internet of Moving Things deployment for the discovery of sustainability optimizations. By constantly monitoring energy consumption and making real-time adjustments, our system can reduce operational costs and environmental impact, helping businesses to meet both efficiency goals and sustainability targets. Lastly, we're introducing Gen AI to simplify the setup and management of intent configurations, which allows users to set up complex scenarios using natural language, making the Internet of Moving Things management more accessible and adaptable. The use cases we're exploring demonstrate how our solution can be applied to real-world challenges with a focus on scalability, real-time decision-making, and resource optimization, while achieving sustainability efficiencies. The main catalyst scenario we will be demonstrating in June 2025 involves autonomous drones in smart ports. Autonomous drones are essential for surveillance, asset inspections, or asset delivery in smart ports. Our solution ensures those drones can maintain continuous connectivity, which adapts dynamically to the in-life requirements of the drone mission. IoT services deployed at the edge are also dynamically managed to follow the drone, guaranteeing continuous service delivery as the drones move across large geographic areas. Through real-time service discovery and seamless handover between edge nodes, these drones can operate without interruption, optimizing both performance and energy consumption. The applicability of our autonomous and sustainable Internet of Moving Things management capabilities may further extend to various other use case domains. Autonomous vehicles in urban environments. In urban settings, autonomous vehicles need to seamlessly navigate and interact with city infrastructure, all while maintaining connectivity. Application of our system would automatically adjust network resources to ensure low latency and high reliability, supporting the vehicle's real-time data needs and ensuring they're always connected and operational. Another example is connected industrial IoT in manufacturing and logistics. In logistics or industrial settings, managing fleets of moving IoT devices like robotic delivery trucks, automated warehouses, or robotic assembly lines is critical. Our solution allows for the efficient allocation of network resources and continuous optimization of routes by ensuring the devices can automatically adjust to network conditions, making real-time decisions based on data from across the system. A final example is smart city networks. Smart cities rely on vast IoT ecosystems for traffic control, waste management, and environmental monitoring. The autonomous capabilities developed in our Catalyst may support such city environments, ensuring seamless coordination between millions of devices with energy-efficient data processing at the edge and sustainable resource management. These use cases illustrate how our AI-driven orchestration and intent-based management will scale to handle the complex, dynamic needs of tomorrow's connected ecosystems and enable the monetization of the 5G network by offering value-added services. Whether it's drones, vehicles, or smart cities, our solution is designed to keep them moving, connected, and sustainable at every stage.